And we are back on stage, everyone. I hope you had a good break. Thank you very much for being with us again. We've got 53 people online at the moment. That's a very, very good number. We are going to start the last presentation of the morning by Simon Uyttendaele on eco-design. Good morning, Simon. Thank you for joining us today.
Good morning.
Good morning. You have a master in artificial intelligence, and very early you've been confronted to the problem of data volume that Jerry just explained before the break. So you started your professional life in geographic information systems, how to make data speak, how to use it on a map. You later developed a state-of-the-art IoT platform able to handle and process massive amounts of data coming from a multitude of sensors, one of the topics that we discussed as well. And this raised, of course, to you many questions related to the actual resources like the energy and computing power required to run such platforms. So as a result, you founded Aeonics and you joined very early the Belgian Institute for Sustainable IT, just soon after it was born last year. And you had one focus in mind: how can the backend processing use less resources to do more? And how can the software participate in the effort to reduce the environmental footprint? So I'm looking forward to your presentation.
Thank you. That's exactly the whole point of the presentation. So the presentation is titled Eco-Design Under the Hood. And today it's not going to be very formal, and it's more going to be about sharing knowledge and sharing experience based on what we have seen on the field. And usually it involves some technical choices and it puts different concepts into opposition. How do you deal with inclusion and accessibility, whereas you have different needs or different constraints? And in the end, the goal is to see whether or not eco-design can be a basis for a business model for an actual company. So my name is Simon Uyttendaele. That's me when I was before Corona crisis, of course. Now I've changed a bit more. And I work and founded Aeonics. It's important to place just a little bit of context to this presentation so that you have the keys to understand what I'm about to say. So when we talk about sustainable IT overall, it usually starts with defining some objectives. The objectives are what you want to achieve. And of course, you have to define then a strategy, which is how do you go to those objectives? And together, this is like related to the governance of your sustainable IT concept and strategy in the company. And of course, usually it targets like the hardware, the devices. Why is that? Because we've seen in the two presentations before, it consumes energy, it consumes minerals, and those are highly negative for the planet. But today, the presentation is going to be on another concept, the one you don't see, the one you don't touch, and it's actually software. And in software, there are many different parts. So we're going to be looking at the hidden part of the iceberg, what is lying underneath, the backend. Now, just to make it clear, the backend, what do we mean by backend? Well, actually, it's not what you see. It's not the application that the user is going to have in his hand. That's actually the server, the engine behind the scenes that is going to power this system and process the data. And of course, it will deliver this information to the application, usually via the network. Now, of course, there are some like cloud-to-cloud system that just process data in the background, that there isn't any visual interface at all. But yet, it's machines that have to work. So today, we will really get our hands dirty. It will go bloody and messy. We'll talk about code, we'll talk about architecture, and also some other considerations. What we want to do is try to evaluate, maybe measure in a way, the impact that we have. And in sustainable IT, we talk about the rules of the 3 Ps. And the first one is prosperity. Now, this prosperity doesn't mean making money financially, no, but it's the prosperity. What is the added value that you bring, the actual thing that you want to achieve, its usefulness, and the scalability that it has. Scalability in terms of evolution over time. Is something that I do today compatible with what is going to come in the future? And how can I adjust my system to take into consideration new concerns, new needs that are going to emerge? The second P is going to be our target audience. And in this case, since we are talking about software and especially backend systems, it's going to be like the system administrator, the one that have to manage those machines, and also the developers and the project managers. How do we take those guys, usually their skills, it's their job, how do we account for them in the system that we are going to design? Last but not least, and I mean, that's the easiest to imagine, is the planet. What's our impact on the planet? And in software, we can, like, it's a shortcut, of course, but we can try to measure the impact of our planet in terms of efficiency and optimization of the process that we are going to have, and the stability over time. Do we need to intervene and go there manually often, or is it resilient? Now, the goal is to bring those three P's together and squeeze them into trying to obtain the whole grail. And that is something difficult because indeed we all know what it is, but no one has seen it yet. Because we have to make choices. It involves to have trade-offs in order to find the proper balance between the cost and the need. And hopefully we're not alone in this process, because thanks to our host today, there are some tools that are put to our disposal and that we can use. And here I'm talking about the Sustainable Digital Services Design Framework. That's a long term. That is designed and maintained by the Institute for Sustainable IT. And it's a set of questions that you can ask yourself in order to try to guide yourself and see how do you define your strategy? How do you define your objectives? What do you take into account? It's a checklist. It's not a checklist, sorry. It's more like different points that try to stimulate a way of thinking. And for each of those questions, they have, like the green card over here, an idea on how it relates to those three P's: the people, the planet, and the prosperity. So we decided in this presentation to use those questions and those cards to give you an idea of whether or not that's important for the different points. And that's the motivation that we have behind the scene. Now, okay, as a company, we have to define the objectives beforehand. Because of those choices and trade-offs that we are going to have to make, it will have a tendency to drive us in one direction or the other, in the other direction. So we need to define those objectives beforehand so that at any time we can come back to it and say, okay, are we still in line? And as a company, for the first objective, we need to be able to take one step back and say, okay, are we doing things in a certain way because it's the best way to do it? Or is it just because, oh, I'm used to do it that way, I don't want to change my habits, so I don't ask even the question? So that's a very important and crucial point. Our second objective is going to be the system we set up. Is it actually answering a need, or is it just justified by trends of fanciness and hashtags like AI, blockchain, data lake, and rainbows and unicorns. What's the actual use? Last but not least, we absolutely need to consider and evaluate the dependencies. What do we bring on board? And to what extent do we enslave ourselves into a system or a technology that we cannot escape? So those points, those questions relate to those cards on the side. And you see it's not full of A's, it's mainly B's. But yet, those are the fundamentals for the strategy and the objectives that we have decided to choose for a company. I'm going to present now 3 different cases of things we have encountered. The first case is going to be about the data size. Indeed, as we have seen just before, how that is of importance. So you have all seen those cameras on the highway. They scan your license plate, and at a later point in time, they scan again, they do the average speed, and they send you a bill if you drive too fast. And in this case, we were one step in a process, and we needed to retrieve the information, the license plate number actually, from this camera system. And we need to store it just for legal and traceability. Whether that's useful or not, okay, that's what we are required to do. So let's consider those 2 points. The data we receive from the cameras, is it compressed so that it uses less resources and less network bandwidth that has a direct impact on the planet, of course? The second question is whether or not there is an open source solution we can use. Well, in itself, the fact of being open source doesn't change much. It's just that, and I quote, it allows to limit the control of certain actors whose practices are unclear and their ambition are not clearly defined. So it's a sort of guarantee that we can have a look and see what's going on. And the solution that was implemented and that we did, it did have it all. Yes. We used a technology which is called protocol buffers. It's being implemented by Google. And it's smaller, faster, and simpler. That's how it's advertised. And guess what? It's open source. So great. All geek that I am, I said, oh, hey, come on. How can that be actually smaller, faster, and simpler? Let's have a look. And that's what I did. And actually, and this is for real, I cannot tell. Open source and clear or unclear as it can be, I have no clue. But it doesn't matter as long as it works, right? So the way it works is you define a data structure, what you want to receive, and then there's a tool that simplifies your work and generates the code for you. And that's very convenient. So that's what we did. We defined the data structure that we want to receive, and we generate the code. And actually, we ended up with more than 30,000 lines of code generated. So you developers, take a good breath, because the day you're going to have to try to go in there is going to be a nightmare. But yet, okay, here it is. We used this code in our application, we compiled it, and as expected, it failed. Yes, it was too easy. So we said, okay, what can we do about that? We said, okay, we will have a look on the actual data that is coming from the camera to our system. What is transiting on the network? And the thing is that with these protocol buffers, you cannot decode if you don't have the proper data definition in the beginning. So it was useless. Yet in the end, of course, the project continued. We got to contact the manufacturer, and we fixed the data definition. We got the license plate, and it worked like a charm. But we noticed that the data actually was quite big, just to receive like this 1, 2, 3, 4, 5, 6, 7, like 10 digits for a license plate. We received like 18 megabytes of data. Why? Because it did contain a high resolution picture with it. And so, taking one step back, the real question we should have asked is whether or not, fancy stuff or not fancy stuff, what data is actually being transmitted. Do we need it? And this simple rule overweights the two previous. Now, okay, case closed, lesson learned. The point here is ask the proper and the good question first. For a second case, we're going to have a look into the code and its dependencies, the weight of the applications. And we had a friend come to me and say, hey, actually, what are the dependencies that you have in your system? And the framework that you use, because of course you're a developer, you use a framework and you use the tools. So what is the impact of that? And then he came and said, we have this new project in my company, and here it's using this technology. What do you think about it? So I said, oh, let's have a look. And indeed, it, like reading at the documentation, it got it all. It is modular, asynchronous. It can be scaled to multiple machines. It's open source. And it's based on Node.js JavaScript technology. And I said, wait a second. If actually it is open source on GitHub and using JavaScript, I know a tool that has the ability to inspect the open source code and make sort of a tree of dependencies of the different things that it uses. Let's give it a try. And this is what it came up with. This spider web, this constellation, is composed of more than 300 different projects and dependencies. More than 250 different, completely unrelated contributors. And guess what? 6 different open source licenses. Well, I hope you have a good legal team to analyze all that. Then, okay, that's the status. We did dig a little deeper, and we saw that one actual library was used in 2 locations in this constellation. Why? Because it was using a different version number. And the reason for that is that the old version contained a security breach, a bug. And so some of the components used the new version so that it did not contain the bug anymore. But some other component did not adapt as fast, and we're still using the previous version. Conclusion is the system overall is still vulnerable to this security breach. Now, okay, who do you contact? As a company, when we work in the hospital and we provide a system to be used in intensive care units, it just cannot fail. And if anything must happen, we should possess the knowledge of the entire system and know who to contact. So knowing your dependencies is crucial, and it's an important point to keep in mind when you design a new system. Now let's go to a second example about dependencies and the weight of applications. We did work with Oracle, the Oracle NoSQL development team in San Francisco. And they had, well, they still have actually, a system running to deliver real-time data all across the globe. And it's related to the luggage tracking when you take the plane. Well, taking the plane might not be very sustainable friendly, but yet that's the application and it's about. And the goal is that it delivers the information with the smallest possible latency, as fast as it can. Why is that? Because of our own trends. The plane barely landed, that everyone is on his smartphone trying to check where is my luggage, who is where, and so on. So we said, okay, we did try to replace their backend system. Well, not the database, of course, but the intermediate system that was connecting to the database and delivering content to the application. Let's see what we can do there. The driver to connect to the database isn't that big, actually. It's 400 kilobytes. But when we pulled it, tried to implement our project, it came with 35 times that size. 13 megabytes of libraries just to connect to the database. Well, there isn't much we can do here. We don't control this component. What we can act on is the actual backend application code and the backend logic. And so that's what it was. It's not a huge project, 25 lines, 25 files, sorry, and it's running the entire system. When you need all the components to run, it's 17 megabytes. It's not huge, actually. But we rewrote it, we reworked it, and we condensed it into something which is more readable, more maintainable for the developers. And now, the total runtime size, the thing you need to make it run, has decreased by more than 2,000%. It is starting faster, it has a smaller footprint, but most of all, for 3Ps, the people that have to maintain it, it's much easier for them to do it in a proper way. And that's the objective that we want to achieve. Now, let's jump to a third point, which is going to be about the architecture, the machines. And that's a very tricky question because it relates to lots of different points. You know, minerals, more machine means more mining, and more machines mean more energy, and so on. So how can we deal with that? Well, again, thanks to the Sustainable IT framework, we asked the questions ourselves. And the machine have the ability to run 24/7. We as humans, we don't. We need to sleep. And therefore, at 3 a.m. in the morning, no one's using the system. And at 8 and at 6 in the evening, there are some peaks. And the system should be able to account for those peaks and be dimensioned so that it has the ability to process this demand. Now, the best energy saving that you can do is just don't use any energy at all. So how can we act on this? This question actually is tricky because the obvious answer might not be as simple as that. Unless you have a physical machine in your garage, you just go there and power it off. The companies usually rely on machines that are located in the cloud or anyway in a data center. You cannot just walk in there. And usually they are working on virtual machines. And if it's not a virtual machine that you have in your data center, anyway, just for managing this set of machines, you would put virtual machines on top. And so it leads to a second concern, because the virtual machine is emulating the hardware. So you have to put an operating system on top and then all the necessary software to run your application. Whereas a container system is a little bit lighter because it only emulates the operating system. So you just deploy your application in there and it's more close to the machine and it's more efficient. Yes, but in reality, what happens? In reality, usually people put a container on a virtual machine. And so the entire idea is completely wrecked. Hopefully, there are some technologies today that can help us manage those resources, automatically scale up or scale down the number of workers that are required to handle the load. And even better, what is called as the serverless functions. It is just a little piece of code that is required to handle a particular request, that runs when it's needed, and that is completely unloaded when it doesn't need to run. I really love this idea. This principle is genius. But it doesn't solve the initial problem, right? Because a function, a container, or a virtual machine, when you shut it down, the physical machine in the data center, it still runs. And don't try to push the problem away. The fact that the cloud provider hides this fact from you or doesn't bill you or doesn't send an invoice because you did shut down your VM doesn't mean that the problem disappears. The machine still runs. So instead of trying to shut things down, why don't we again take one step back and ask ourselves, why did we need that much processing power to begin with? And how can we maybe better handle those peaks while keeping the infrastructure minimal? Well, let's analyze a little bit. When multiple components run on one system, they enter into competition for resources. And this is the number one reason for virtual machines in the beginning, so that one process doesn't affect another one. We isolate those processes. Now, what if we could change this behavior into collaboration instead? What if the components behave well? Then the pressure on the system decreases and it's more efficient. And we are talking about a data center here. So it means that the main power consumption is directly linked to the CPU, the processing unit. And this is why, by the way, modern CPUs, the chip itself, has the ability to change its clock frequency. It can work faster when there is a lot of things and a lot of pressure. It will try to increase its clock frequency so that it can manage the load of things to do faster. And on the other way around, when there is nothing to do, the CPU logic has the ability to decrease the clock frequency so that it doesn't use as much energy. And it's, again, a shortcut here. We can debate this later. But basically, the power consumption is not linear. It's exponential. What does it mean? It means that when I use 60 minutes an hour, my CPU at 2 gigahertz is going to consume around 40 watts an hour. And if I use my CPU half of the time, but 2 times faster, so the same quantity of work, it's going to consume actually much more energy. Now, the absolute number here is not relevant. What is important is the order of magnitude. And this is why we tried to work differently. And instead of turning on and turning off some machines to handle the load, we decided to absorb the load by queuing the tasks. We dissect the things to do into smaller tasks and we put them in a queue. And of course, the amount of things increases. But yet we can accept excessive amounts of requests and process them, whatever resources available we have. But of course, as I've said previously, if there are more tasks, it puts more pressure on the CPU and on the system, and it will consume exponential amounts of power. So that's why we introduced our own collaboration algorithm. And basically, it constantly monitors the system and tries to follow what we said, what we define as a load target. So we say, okay, what is the ideal, optimal load target that we want on our machine? When we let the backend run freely on one machine and we boost it a little bit, and we don't set any load target, like the load target, go ahead, use 100% of the system. We see that the CPU increases its frequency to 4 gigahertz. And just for the ID, on one system, it means we can process 100 million web requests in half an hour. It's pretty decent, and the response time is 0.1 millisecond. Now, if we set an actual load target and we say, okay, now I don't want the system to overconsume. Please try to restrain and leave some space so that it reaches around 80%. Well, we actually see that the frequency is almost at nominal speed at 2.6 gigahertz. It consumes less energy. Yet, in an hour, it processes overall the same amount of requests, 100 million on one system for an hour. But this time, of course, the response time is twice as much, 0.2 millisecond. So what it did actually is dissect all those requests, put them into queuing with this much number of tasks to do, and it try to organize it in such a way that the different tasks don't compete with each other, but they collaborate into freeing the system. Now, the real question here is, do you need this 0.1 millisecond response time? Or can you afford 0.2? What is going to be the difference for the user or for the system to have a response time of 0.2? And if you really need 0.1 millisecond response time, what is going to be the impact on the planet for that? And that's a choice we have to make. Now, as a conclusion to all of this, and to answer the original question, which is, can eco-design be the basis for a company? Well, basically, yes, it can. And there are some actors that can help you with that. There are no right and wrong answers. Sometimes you have to choose between conflicting ideas, but the most important thing is to try. And it might not work as you expected in the first place. And in that case, it's important to just try again. And this is how we've managed to come with a backend solution today that has 0 external dependencies, and that takes into account the various other concerns related to sustainable IT, different questions that we ask ourselves, and that actually works, and it works well. Now, given the time that we have left, I'm trying to see here, because I have to keep room for some questions, I might actually give you just a little example, a live one, like hopefully the gods of demo won't be against me today. So I'm going to try to share a different part of my screen, if I may. Just a second. I'm just going to run the backend system here. And I am going to simulate, let's say, 1 million web requests to my backend. And we'll see what impact it has on the load of my machine. So if I'm going to the status page, I can have a live view of what's going on. And we see here that the system is, the thick blue line is almost idle. My system does nothing right now. If I stimulate it by doing those million requests, we'll see that, well, actually, it is going to raise my CPU utilization to 100%. That's the thin blue line. And my own system is only able to use that much because sharing the screen, and my other system, which is running right now, is taking also. It enters into competition. So what I can do instead is say, okay, 1 million requests, done. I'm going to enable the load target. And I'm going to set it, just for the sake of the example, to 60%. This is going to be my load target. Well, even lower, because we see that it reached barely this amount. So let's see, 50. Now I'm going to try again 1 million requests, and let's see what's going on. We see that now the system is going to try to adjust and decrease its own internal processing power so that different applications and the overall system is just below 100%. So that now the frequency of my CPU can be at nominal speed. I don't need an increase in frequency. I don't need to consume much more power. And of course, as expected, it's going to take more time to process this million requests. And the system is constantly monitoring that. And of course, queuing all those requests does have an effect on the memory. So what happens in the memory, we see it here. It is queuing the requests and then freeing them. The idea is that the system should be optimal. And we see here that we allowed 1 gigabyte of memory to be used. So the system is at ease. It has enough. And it has allocated 260 megabytes. But that's not actually what it needs to run. That's just free space available. If I'm asking the system, please now optimize, let's see, that's the actual number it needs to run, 6 megabytes. For a backend system to handle 1 million web requests in what? 15 seconds? So it is possible. And the real question is, do you need to be fast? Or how much can you afford to be less fast? Well, that's going to be it for today. Thank you very much. And Olivier, I'm open for questions.
Thank you very much, Simon. Excellent presentation again. It's always interesting to see in more details, technically, etc., what this means, and very happy that the god of demo did not fall onto you to block the
yes, me too.
Thank you also for making reference to the tool that our association in France and Belgium, etc., are publishing, like the Sustainable Digital Services Design Framework. I must really congratulate my colleagues in France and all the contributors in the community who have helped to create that content, and also Remy for putting all that in a user-friendly web page on our international website that we are building more and more. We really aim to provide more information. Just a quick reflection. I listened 2 days ago to a presentation by Joanna Moll. She's a Spanish researcher and also an artist. She does research on topics including internet materiality, social profiling, interfaces, etc. And she tries to present the results in an artistic manner in museums, also universities, etc., so that we understand the materiality behind that. And she took the journey of an Amazon user just wanting to buy a book, and the shortest journey, if you don't already have all the setup done, but you need to pay for the first time, etc., on Amazon. And the amount of code that was generated was 87 megabytes, and there was something like 1,300 requests all over the place. And the way she shows that, she printed that on paper. More than 8,000 pages of paper that were shown in museums next to just the book, to say, okay, that's what you get when you buy a book. That's the amount of data that is transmitted, and it's amazing to see the quantity of data you mentioned with the automated code generator, etc. One of the questions I have for you, which is slightly on the side of the presentation, is from a business model perspective, looking at your costs on one side and also your clients on the other side. Would you say that the eco-design principles that you are applying bring you a competitive advantage?
That's a tough question because, as you, Olivier, knows, we created the company 2 days before the first Corona confinement. So it means that our business model didn't really have the time yet to be proven, but the different aspects, and one which really we put emphasis on is the people. And we truly believe that there is today, burnouts especially in the office workers, those aspects of stress, difficulty, learning curve, and so on, that is going to have an increasing importance. And if we can put something that has definitely some advantages on the resource point of view, but that also addresses this people point to P, let's call it that way, it's really going to give us some advantages in the future. Now, of course, it's like everything we do. Sometimes I do throw something in the wrong garbage can, and I tell myself, oh, it's not such a big deal. But then if everyone is doing the same, then it is a big deal. So it's about also, like today, what we do, propagating the knowledge and the idea of sustainable IT. And as it grows and as it is better understood in different companies, I think it will have a strong impact.
Okay, indeed, yeah. In that respect, I'll change the topic in a minute. But just coming back to the questions that I have in the chat, Delphine. Oh, you mentioned the 3 Ps, of course, in your presentation, and you just mentioned one of them again. Thomas was mentioning that we could add a sort of impact, P for peace, and also P for partnership with regards to social networks, for instance. So there's so many aspects. You mentioned people again. I think it's really one of the keys now in how, especially the youth, is looking at new jobs, new companies, etc. They really make a choice based on purpose of what they will be doing. So that's a different ball game, I think, for many employers now. Delphine was asking, what about starting with code from scratch rather than using open source or existing codes? And what are the eco-design fundamentals for our developers?
It's always, sometimes you don't have a choice because you have to deliver something and you cannot afford. I could just write my code in assembly, like the first computer language. It's not even a language, it's what the machine does. But at some point, I'm going to be so unproductive that it cannot work. So again, sometimes we have to deal with a framework, and okay, that's the starting point. So that's also what we have been trying to set up as a company, is define our own framework. So in a sense, we say that, okay, we try to limit the use of framework, yet we provide one, of course, because what we believe is that if we try to work, developers, if we work with higher concepts than just low code, it might bring more understanding of the meaning of what we are doing. And that's what we try to put the emphasis on in our framework, is that we work with functional aspects and not technical one, like 1 + 1 + this number with this number of decimals is. No, we try to say, okay, it's a value that can be used to measure something or to quantify something else. Whether or not it's a floating point number or something like that, it's important, but it should not be important for the developer.
Okay, thank you. I don't see other questions in the chat for these particular discussions. I don't know if you have an additional.
Well, I've seen one actually, because I'm looking at the chat at the same time. Is it correct that the container duplicates the operating system for each container? The answer is yes. If it is the same operating system as the native one it's running on, it doesn't have to duplicate the kernel operating system. But when you have an empty system, there are a list of native process. Even if you don't have your own process, there's a list of native process that run anyway. And indeed, since it's a container, those processes have to run anyway. So it's starting and duplicating those. So indeed, if you can afford not to have a container, not to have a virtual machine, it's going to be more efficient. But you have to deal with people too, and that's the balance and the trade-off. Because then to manage and to scale or to migrate to a different environment from production to development, how more difficult it is going to be. So it's always, there's no right and wrong. It's trying to find a balance and always think about what could be my impact. And I may do something which is, I know it's not good, but given other factors, it's the best I could do.
Yeah, I guess it's the same type of answer that you could get to the question that was just raised in the chat about the cost actually of developing software properly, I would say, compared to using open source resources. Is it just affordable for small developing companies? I guess it's a choice to make at some stage, and sometimes use open source code, and whenever you can, not use it to minimize your impact.
Yes, well, then it is indeed the real question, as I think Gary said just before, we are lazy. Let's face it. And if something can be out of the box and pre-done for us, it's going to be easier and cheaper.
Yep.
But just as I would throw my garbage to just one single container, it's easier, and it might or might not be cheaper, but it's going to be easier for me. Now, of course, it means that there is a cost associated to doing things properly. And the first one is taking the time in the beginning to ask the proper question. And it might not be easy because, you have a customer that says, I want this. Now, are you going to challenge that? Are you going to tell him, is it really what you want? And yeah, it's not that easy, but that's something we can work with them. And by having, little bit of experience over time, it stacks into global knowledge. And then you can have cues to asking them other questions. And instead of saying, well, are you sure? It's going to be, oh, did you think about this aspect? Did you think about that? And basically bringing those questions will drive them to a more insightful meaning of what they really need, actually.
Yeah, but if we compare to the mining that we saw in the first discussion this morning, first presentation, it's a bit the same. We can mine everywhere and just dump pollution all over the place, or we can try and find ways to have minimal impact. And the question now, from an economic point of view, starts to be: do we just want to enrich ourselves, and so be it for the planet and the rest of humanity, or do we want to have to reduce our impacts? If it's okay with you, Simon, I was contacted in the chat by Thibaut. He kind of manages, or I don't know the exact word, Ecopreneur Belgium, which is really trying to help companies like yours to find a place in Belgium and in Europe by showing the advantages for themselves, but also for clients, etc., to use services like yours. Would it be okay if I invite him on the stage so that he can give us a few words about Ecopreneur?
Sure, I think it's a great idea, yes.
Thank you. We'll see if he accepts my invitation now. That would be... There he goes.
So now put the camera on.
Okay. Hello, Thibaut.
Hello, Olivier. Hello, Simon. So it's really interesting to listen to you. So a short word about Ecopreneur. Ecopreneur is the business federation of sustainable entrepreneur. And basically, I mean, your conclusion was pretty in line with what we are doing, because being ecopreneur or doing things rightly is, in most of the case, more complicated than doing things simply or by using solutions that are not sustainable. And so one of our key, let's say, mission is to make sure that there is a kind of financial advantage when you do things properly. And that's the kind of lobby work we are doing, both at local level in Belgium, but also at European level, because most of the regulation are discussed at the European level. And so how to make sure that someone doing business properly and sustainably can be rewarded with some incentive, or at least in relative terms with non-sustainable player. And that can be a leverage in order to motivate people to go that way, but also to incentivize players like you, Simon, to support companies in not only doing something, but doing something sustainably. So that's what I would like to mention. I think that it was really interesting to listen to all of you this morning.
Thank you.
Thank you.
Don't hesitate to share the link. I'm just looking for it. Is it ecopreneur.eu?
Ecopreneur.eu is the European level, so representing 3,500 companies in 7 countries. And Ecopreneur Belgium is the Belgian association. And in France, we have our contact is Entreprendre Vert. That's also quite easy to find on LinkedIn, at least. And that's also a kind of organization promoting, let's say, and defending the green and the sustainable business in France.
Okay, thank you very much, Thibaut. I'm reverting back to the discussion, more technical discussion that I see in the chat. Thank you for sharing information, Thibaut, about Ecopreneur and the equivalent in France. Simon, I don't know if you want to react to already to what you see in the chat, open source, etc.
Well, yes, and it's a very, a passionate discussion, because there are some advocates of open source, not open source, and different methodologies. But it is indeed something that we encounter on the field, is that it makes people uncomfortable. Because when we go somewhere and tell them, well, it might not be the best way to do some things with respect to sustainable IT, then they feel a bit attacked into their knowledge and their skills, and they are threatened by this speech. Mm-hmm. So it is also trying to, again, go one step at a time and take care of those guys, because they are your best partners into implementing a solution in the end. Mm-hmm. So facing them into opposition isn't going to solve anything. We have to bring them on board. Mm. And it's very difficult, but okay, I think discussion and having an open mind discussion, because I might be right, but I totally can be wrong. And discussing it together is the best key to approaching something that we can agree on. Mm-hmm, mm-hmm. So I have a specific question here, just to take it back, is how do you cope then with the agile way of doing things? Because indeed, the customer wants something immediately, as fast as possible. And I think it is exactly the essence of what I said earlier, is by trying not to have a system that is going to bind you to one technology and so on, but that is still open and flexible, that is going to provide you the key system to evolve over time and go one step at a time, in an agile way, but keep the system open. And I didn't say open source, I said open. And because over time, when there is a technology change, it's important that you can replace some components. And even the system that we do provide, the idea is, can we find a way so that our own system can be replaced at any moment? And our goal is, yes, we shoot ourselves in the foot, of course. But for sustainable IT, that's the case.
Yeah, I think in Agile, there's multiple ways of looking at it. Agile does not always mean being really fast. It means bringing faster things that can be started to be used and without having the full product delivered. It does not mean that we should not be doing the proper design. And it's a bit like buying a crappy device or taking the time to find the right device and buying that device. You have a completely different type of environmental impact because of the lifetime that you're going to keep that, etc. Also, when you start coding in an agile manner, you can do something which is a bit crappy at the beginning, but at least you know if it's used or not. Then you can refactor it so that it becomes more efficient without having spent too much time creating the perfect design from the start. So agile and speed of delivery, etc., do not, for me, do not go against doing a proper job and doing eco design in IT, like in other types of businesses, because agile can be used in other types of works than only IT, I think. Okay, thank you. We have just come at the end of the time. If there's no other urgent comment on which you want to react, I propose that we stop for lunch. Just to remind you, you will have let me share quickly my screen again. There you go. So we are having a lunch break until 1:30. During the lunch break, you will have the opportunity again to use the networking lounge of Hermit. Don't hesitate to use it anytime during this period. I guess that probably a bit closer to the end, we will find a bit more people again on it because people are probably hungry. And if you are watching us on YouTube, the stream will now be interrupted. And if you go back to the page at 1:30, you will be able to start a new live broadcasting with us. So enjoy your lunch. Thank you again very much, Simon, and also last minute Thibaut for joining us. And see you at 1:30 for the next talks. Thank you.
Bye.
Thank you.